Yeah, so today I'm going to talk about PySpark. Good morning, everyone. So, PySpark, big data processing using Python and Spark. Okay. Now, first question comes: what is PySpark? So, PySpark is a Python library that helps people working on large amount of data. So, it helps those people who are working on large amount of data, and it is using power of Apache PySpark. So how this word PySpark derives? It is the it comes with Python plus Spark. That is PySpark. So as it imply, like we can see, it includes both the functionality of both Python and Spark. So Python is a popular, versatile, and beginner-friendly programming language, which is known for its readability and extensive library. So no need to say that Python is very popular these days due to its user friendliness. We like the person who is not very much knowledge, the person who does not have very much knowledge of computer programming language, he also can do the programming in Python because it is very much close to the English language. It is very much high level language. So it is very easy to do the programming in the Python, and it supports many of the libraries. So that's why Python is very much popular. And when what is a Spark? It is a powerful big data processing framework that is designed for speed and scalability and ease of use. So for while it comes to handling the data, big data, like which is in exabyte or terabyte or petabyte, this kind of data if we need to handle, then Spark is a very powerful tool for that. But what happens, like when you have to use Spark, then you should have the extensive knowledge of big data handling and how to handle the tool and Hadoop functionality and all thing a person has to know. So the person who does not have so much of knowledge of all these big data handling languages and all, it is not easy for him to work on Spark. But PySpark provides that facility, then that you can write the syntaxes of Python and use the libraries of Python, and then you can work on the Spark. So it is a framework which is designed over the Spark and which can use the syntaxes of Python. And also the advantage of the Python, because Python is embedded with that. Now here are some key points why we should use PySpark. So there are so many advantages, but I have just mentioned few of the key feature of PySpark. We can say key feature or we can say the advantage. What both are the things. So few key points are like distributed data processing, resilient distributed data sets, which are RDDs, commonly which we call RDDs. Next is data frame API, Spark SQL, machine learning with MLlib, Spark streaming, integration with Python ecosystem, scalability and cluster management. So these are some key points of PySpark. I will briefly discuss these key points in next slides. So the first thing comes is like a distributed data system. So in my previous talks also, I have already discussed about distributed data system. So I will just discuss briefly about this. So what is a distributed data system? It is the process of splitting and processing data across multiple computing nodes or machine within a network. So this picture shown clearly, I have taken it from Google. So this we can see that there are multiple databases where the data has been distributed. So as the data is very large and very huge, so it is not easy or it is not possible to store the data in a single node or single machine or single place. So so we have to distribute the data uh, on the multiple machines, on the multiple places, so which is necessary to store the use amount data, as well as which is which gives the ease of use, or which gives but which makes easy to process the data. that high amount of data, if you have to process, you have to do some, you have to analyze that data, then it is good to have the distributed data. So it provides parallelism, data partitioning, fault tolerance, scalability, high performance, and many more advantages. So obviously we can say if there are multiple node available or multiple machines available, and data is distributed on those machines, then it will provide parallelism. So Python supports that distributed data system. So parallel programming is very much easy for Python, PySpark. Also data partitioning. So data is, we can partition data, the data on the basis of some key. So it is very easy to search some specific data, because for example, if we have partitioned the data on the basis of some range, we can say from 1990 to 2000, data for 10 years of data is available in this node, and for next 10 years of data is available in that machine 2, and for the next 10 years it is available on machine 3. So whenever you have to search on the like hexabyte or petabyte of the data, then if you have to search the data of 1995, then you will directly go to the machine number 2, because we know that from 1992 to 2000 data is available on machine 2. So that is data partitioning. So it makes to process the data or search the data very much easier. Next is fault tolerance. So when it comes to fault, it is, if it is a distributed system, then if one node fails, then it is easy to it is easy to recover, as well as our system will not crash because we have multiple nodes. Either otherwise, if you will have only one node or one database, if it gets crashed, then your system will also crash. You will not be able to work until that will be restored. So it provides the fault tolerance. Next is scalability. So what is scalability? That means it scales the resources. Yes.
Are you changing your slides? Because here I'm not seeing any change in your slides. So have you changed?
I'm not changing. Sorry, I'm just reading these points. This data partitioning, fault tolerance, scalability.
Okay, fine.
So next is scalability. How the scalability comes, like if the number of resources are required very much, like if the you have workload, like you have so many like workload or very high workload, then it will add the dynamically, it will add the resources, or if you don't need, then dynamically it will reduce the resources. So it provides multiple features. High performance is also there. So distributed data system is very much useful to handle the big data, and PySpark supports that process. Next is resilient distributed data set. So commonly we call it RDD. So RDDs are foundational data structure in PySpark, a powerful open source framework for distributed data processing. So as we have seen that data is distributed among the multiple nodes, now we need some kind of data structure which can work over this distributed data system. So which will support that data structure, will also support that uh, distributed data system. Then only we can say that PySpark is supporting distributed data system, because it has some of data structure which work across the nodes. So RDD is that kind of data structure. So these are distributed collection of data, allowing you to work with data sets that are too large to fit into memory on a single machine. So now what happened, we can see in the diagram, there is a driver node, and there are multiple worker nodes. This diagram also I have taken from Google. So there are multiple worker nodes available. So you have the data in multiple worker nodes, and the data, all the worker nodes are processing data parallelly. So now there is one data structure RDD which contains the data across the nodes. So for example, you have to work on some 1 billion of the data which is present in some file. You can say in CSV file you have some 1 billion records. Now you have to work on that data. So that data is too large to fit into memory for a single machine. So if you will read that data in some data structure of some language, so it is not like the cache memory will not support only for the single machine memory. It will not support the 1 billion record from a in a one like together 1 billion record will not be supported by a cache memory of single machine. So this RDD distributes that data structure into multiple machines at a time only. So with this RDD, the PySpark can easily support the distributed data system. Next is data frame API. So data frame API are distributed collections of data in
Richa,
PySpark. Yes.
can I ask a question? Could you please go back to the previous slide?
Mm-hmm.
So just for clarity, so here work. So you said that the computer may not have enough cache memory so that it can keep this large amount of information in it. So when you
Mm-hmm.
say, so then are you doing this computation on different systems, or so what is the meaning of worker node? So my understanding is that you are, so by the looks of it, when you say worker node, it means that you are distributing the, let's say, the reading part of the data into multiple processors. Is this what
Mm-hmm.
you are doing?
Yes.
But then is cache memory depend, so does it depend upon the number of processors, cache memory?
I like what I'm saying. You have one CSV which is stored in your some of your system, maybe some of your database, or in your local system. Now you are reading that CSV in some data structure of the language. You need to do some transformation or some analysis. That
Mm-hmm.
will be done in the in memory. We can say RAM or we can say cache memory. So
Mm-hmm.
if the data is very much large, so your system will not be able to read all of data at a time in that cache memory. It will not be able to read as well as it will not be able to analyze that data. Now,
Mm-hmm.
what RDD will do, if you have four nodes available, the parallelly in the cache memory of all the worker nodes, it will be done. So maybe it will be distributed like one fourth, one fourth, one fourth to each of the worker nodes. So they will be able to handle and do the transformation on the data. So we can say combining of the cache memory of all the machines, we can say like that.
So you're working on a single machine, or you're working on multiple machines?
Multiple machines.
Oh, multiple machines, ठीक है.
Yes, yes. So worker node means one worker node is a one machine.
अच्छा, okay, fine.
Hmm. Yeah, so there are four machines. It can be located at the same place or it can be on different cities as well.
अच्छा, ठीक है, okay,
Mhm.
okay, thank
So
you.
it provides a facility, then all the machines are working together on the cache memory itself.
Mm-hmm. ठीक है, okay,
Okay.
please continue.
Okay. Yeah, so next is data frame API. So data frames are distributed collection of data in PySpark. So it is also again distributed collection. So everything in PySpark will work on a distributed manner. Now, what is the data frame API? It resembles tables in relational data set database with a structured schema. So we know that in the relational database like Oracle, we have tables available for the storage and for the every type of operations. So tables has a specific schema, means there will be some column names like name, age, department, this kind of column we will have, and according to those columns we will have the data. So that kind of proper format, or we can say structured schema, we maintain in relational database. Then it is very much easy to query on that database or do any type of analysis on that database. So these data frame provides that kind of structured schema to us in PySpark. So it also work on the distributed manner only. The only difference with RDD and data frame is like the RDD is very low level design and data frame is high level design, which is easy to use for the easy to understand and easy to use for the user. And the RDD does not contain the structured schema. No, it doesn't have any structured data. It has the unstructured data and it does not have any schema. So it is not easy to do the operations on that. But as they are at low level, they are very fast. So in data frame, we can create a structured schema. So we can say we can create data frames from various sources like CSV, Parquet file, JSON, or existing RDD. So if you have CSV, you will directly read the CSV in the data frame of the PySpark, and that the CSV will if CSV have some of the header, so that header will exactly come in the data frame, and the rows will also come in the data frame as that is. So it will create a table kind of a structure. Now you can directly read the CSV from the built-in Spark function like spark.read CSV or spark.read.parquet. Like it depends on your file type. You can read easily. After that, you can apply various operation on data frames like select, filter, group by, count. So when you'll get data in proper structured schema or proper tabular format, then you can apply all the operations which you can do in the table. So you have
Richa,
to select. Huh?
you also have pandas available in as one of the
Yes,
libraries
yes.
in Python. So is Spark advantageous on pandas in some manner?
Yeah, so pandas is also available in Python. So yeah, like I will come into in the next slide also. Like panda is also provides the data frame. So I was telling that some of the advantage Python individually have, and some of the advantage Spark individually have. So independently, they both are a very good languages, and they both have extensive libraries. So now when it comes to combining of them, so we can have the advantage of both of them. So whenever you find that Python pandas data frame is good, you can use that pandas data frame in PySpark. And whenever you think a Spark data frame is good, you can use the Spark data frame. But
Okay,
we
so
can say like for handling the big data, Spark is especially designed for that. So Spark
acha,
data frame are
okay.
like very like they does have many operations and inbuilt functionality which can be done on big data specifically. So these are very much useful when you it comes to for big data.
Okay, so then one more question. Okay, thank you. So then please correct me if I'm wrong. So then Spark is not a Python library.
Spark is not a library. PySpark was the library uh, to connect both of them. When you have to work on like Python plus Spark, then there's a library PySpark which have all these function which will connect to Spark, which will connect to Python to Spark. There is a library PySpark, but Spark is not library. Spark is a different software, or we can say it is a different tool
Okay,
which
so
is
when
entirely different. You can work on Spark using some other languages also.
acha.
Mhm.
So when you want to use PySpark, you have to install Spark and Python independently.
Yes, yes. And
Okay,
then you have to connect them using PySpark library.
okay. Thank you so much. Okay, got it.
Mhm. Yes, yes. So I will showcase these things in the next slides. So now we can say, yeah, we can apply various operations on data frames like select, filter, group by, count. So it makes easy to do all these things. Next feature we can say Spark SQL. So when you are using Spark, or you have the data in the tabular format, then there should be support of SQL programming. Then only it will be easy to work with the data. So PySpark provides us a Spark SQL. Spark SQL is a inbuilt functionality of a Spark. It does support the SQL environment. So with the Python also, it starts supporting Spark SQLs when it comes to PySpark. So we can say Spark SQL enables SQL like queries on unstructured data. So now here we can see like we can use the Python programming also, and see in the on the same time we can use the SQL programming also in the PySpark. So whatever is more suitable for you, or what is the better approach for your data, you can use that kind of programming in that PySpark. Both work together in the single program. So we can say it integrates the SQL capability with PySpark data frame and RDDs. So we can example spark.sql select star from table name. So that is purely SQL query, but you can use it in your Python program while you are using PySpark. So that is the like you can say that is an integration. Now we will talk about Spark streaming. That is also a key feature. So these days, streaming is very much important. Spark streaming is a real-time data processing module in PySpark. So streaming means real-time data is coming, and normally how the big data, how the data becomes the big data when generally it is coming live, is live or streaming is there. Like for example, on the real-time scenario, we are checking the like share market trading and all. They take the data on the real time, and for the every website they monitor all the users and the traffic on the real time. So you have to take the real time data and you have to analyze that. These days this is the very much required thing on the business for the businesses. So it handles data in mini batches, making it suitable for stream processing. Example real time use case are like monitor website traffic, user interaction, click stream data in real time, or calculate real-time metrics like page views per minute, active users, or session duration. So one of the example I can give you, like if you select some product on Amazon, or you see some product on Amazon, then uh, just you just finished or not finished, you just come to next product, and it start showing that on the on like um, on the like last part of the page, it starts showing that you recently viewed this product, or your viewed history, or you may like this product also. So on the real time, it is taking data from you and it is processing and giving you output. So you can understand how fast it is, how it is working on real data. So this kind of streaming is very much required in these days. Also the website traffic, you have to monitor how many users are there, or what is the traffic. Accordingly you have to manage your system. So that kind of streaming data is very much useful. So PySpark support that Spark streaming also. Next is integration with Python ecosystem. So obviously we have already seen that it is PySpark, so it will come with Python system also. So we can say like PySpark is the Python API for Apache Spark. So it provides the seamless way to use Spark's capability within the Python programming languages. So PySpark and Python both will be there in the PySpark. It allows you to write Spark applications, leverage Spark library, and interact with Spark cluster using Python. So Spark library will also be there, and it will interact with Spark cluster also using Python. You will not need any specialized skills for interacting with Spark cluster. PySpark can work seamlessly with popular Python libraries like NumPy, Pandas, SciPy, and all. So here you can see Pandas also comes into picture, NumPy also. So whenever you require these kind of functionality, you can use this library also. You can use Python visualization library like Matplotlib, Seaborn, Plotly. So we can say like obviously when you are analyzing the data, you are generating some result from the data. So maybe this is very this is very obvious that you will need some charts or some graphs for the data, how the data is varying or how it is performing, like this kind of data you need. So for creating these charts, we can directly use the Python libraries which are available there. So if you work directly on a Spark, that making the chart and all will be difficult for you. So now it comes to Python, then you can directly use the Python library to creating charts and graphs. Now, PySpark data frames are similar in structure to Pandas data frames, making it easy to transition between the two. So that is the question of your that is the answer of your question, that we can switch between two. The PySpark data frames, like Spark data frames, comes into picture. It is very similar to Pandas data frame, so you can switch whenever you want, or like what is familiar to you according to your need. You can switch between the two.
Okay.
Yeah. And machine learning are also a key feature of it. It has machine learning libraries, and it provides a powerful tool for model training, model evaluation, data preparation, and all. It is useful for machine learning also, and scalability and cluster management. So PySpark supports various cluster managers like standalone. Standalone, it means only a single machine you are using. only one cluster, like on a cluster, only one machine is there. And other cluster managers are also, it can handle the resource allocation and job scheduling. So it is very much important in while you are handling a distributed data system or cluster. So that cluster management is very much required. So PySpark supports dynamic allocation of resources, optimizing resource uses based on workload. Idle resource can be released and additional resource can be allocated as needed. So how it works? For example, sometimes you have like high workload on your system or your site, and you need, if you have n number of resources, you need all of n resources. So it will distribute the workload among all the n nodes. But for example, sometimes you don't have much traffic, you have a low number of users, then you don't need n number of resources, you only need n by 2 resources, or we can say nodes. Then what it will do, it will release uh, the remaining n by 2 which is not required. It will allocate the data, it will distribute the workload among the n by 2 nodes only, and that n by the idle n by 2 resources will be released. So you will save the cost, you like that you will not use the you will like it will not be engaged with your system, the resources can be used somewhere else, or you will save the cost also. And if you will require n plus 1, then also it will take the additional resources from the cluster manager, and dynamically it will do all these things. So that is a very important part when you have to work on the cluster or distributed system. So it work like dynamically, it can work like that. So these were some key features which I have discussed till now. Now we can just practically see how we can start with PySpark. So when you have to start working on PySpark, especially on your machine, I'm just telling how can you do in your system at least. So what is the step one? First of all, you have to download Python using official website. So you will download from www.python.org, and then you have to run the installer. So when your Python will be installed, you have to set some path also for Python that you can do according to your system. So when Python will start working, you have to set up a Spark. So download Spark from official website and install the same after unzipping the package. So you will get a zipped package. You have to unzip that. Then you have to download Spark. So the official website is Apache Spark. So we can say Apache spark.apache.org. That is the official website. Now you have to ensure that you have Java installed in your machine, because Spark runs on the Java virtual machine only. So if you don't have Java, then you have to install Java as well, and it will run on the Java virtual machine only. Now you have to configure environment variable. So for the Spark, so you have to set the path of your Spark so that Python can understand where is the Spark located. Next is you have to install PySpark library in your Python interface. So maybe you are using Jupyter Notebook, or you are using PyCharm, whatever you are using, you have to install the Python PySpark library by using simple command pip install PySpark. And after that, you can run your code on the PySpark. So I can just quickly showcase how to do that. So first, you need to download the Python. So this is the official website of the Python download. You can download Python 3.1 11.5, that is the latest version for Windows, and for other OS also it is available. You can install as per your need. Next is you have to download Spark. So this Apache Spark is the official website of this Spark. You can download from here Spark as per your configuration, or the version which is required for your system, like 32-bit, 64-bit, whatever is required, you can download from Apache Spark.
Is it
Okay.
also available for Mac systems?
Yes. So maybe you have to find out, because here it is showing the Mac OS. The same way it will available on Mac also.
Achha.
Okay, and then we have to set the environment variable. So I'll just show what is environment variable. So if you will type, it is the part of your system only. So if you will type environment variable, it will showcase you what are the environment variable for you which is already set up. So here many of the environment variable are already set up. So I'll just showcase you the path variable. So here multiple paths are available for like if you have to like for the Python you have to add the path of Python, like I have added here Python, and for the Java you have to show add the path of Java. So in the same way, if you are using Spark, you are using Hadoop, you have to add the path of all of them in the environment variable. After that, you just you will just need an interface of the Python, maybe PyCharm, Jupyter Notebook. So I already have this PyCharm interface available here.
Richard, one
So
more question.
mhm.
Can you not do that adding something to the path using bash
Yes,
terminal? Acha.
yes, you can do from there also.
Okay, okay, okay.
Mhm. Now here I just in the terminal I'm just installing PySpark. 1 minute. Just a command pip install PySpark. I've already installed it, so it is showing that it is already satisfied. Otherwise, it will install the PySpark in your system, as you have already installed the Sparks in your system and you have set up all these things. So now you are good to work with PySpark. So here the small code I have written to showcase how we start with PySpark. So from first of all, we have to first of all, this line from PySpark.sql import Spark session. So on when you have to start working with PySpark, you obviously you will need the PySpark library, and you have to import Spark session, because you have to create a session between Python and Spark. So that is that like PySpark is a connectivity between both of them. So what it does, it to create a Spark session, and with that session only it works with a Spark. So here Spark session is already pre-built function here. So we have to just import that Spark session, and from this Spark session you have to create an object of the session. So I have created an object Spark equal to Spark session dot builder, app name equal to RTB, whatever you want to give, and get or create. It will create a Spark session object. Now you will use this Spark object wherever you will need any of the Spark functionality or any of the Spark thing. Whenever you will need, you will use that Spark object. So here I have written a simple code of reading a CSV. So here is my CSV, which is I have taken the sample data of credit card fraud detection. So it is the data of credit card transaction sample data. So you have to take this data and analyzing. You have to analyze like in which city the transaction is being done, what is the anomaly in the data. So for that you have to take this data in your sum of data frame, and you have to do all the operations and performance transformation. You have to analyze the data so that you can identify if everything is normal in this transaction, or something is fishy in this. So I have how many records are there? Approximate 5,55,000 records are there. Okay, so this is a CSV. Now what you can do, I have given my CSV path here, and just there is a inbuilt function is spark.read.csv. You will provide your path here. Header equal to true means it will take all these headers also in the data frame. Otherwise, it will not take. It will directly start from the rows. And for schema equal to true means it will take the schema as well. Schema means it is a date format. It will take it as a date. It is a string. It will take this column as a string. It is a integer. It will take it as an integer. Otherwise, if you will not give the infer schema, by default it will take all the columns as integer, as a string. I think by default it takes as a string. So how like DF is a data frame, which we have already talked about, data frame API. So this data frame DF will be created by using this CSV, and then df.show is a function. So there are 5,55,000 record, but you have specified here 100 records. So on the console, it will show only 100 records, but the data frame will contain all the 1,000, all the 5 lakh record. So now I will comment out this line. So I will just run this code. So initially it just create the one session. It just connect to Spark. So initially this part takes some time. So after that, the whole code will not take much time. So here I have written the small code. So maybe it will not showcase the specifically the power of Spark, but yeah, we will get some idea. Okay, so this 5 lakh CSV is has been read in a few of the seconds, not in fact not the seconds, because it mainly the time took to create the session only. So this reading part was very fast. Okay, so now we can say that this all this data of the CSV came in the our memory, and it is in data frame. This kind of tabular structure we are having here. Now you can read the data, that transaction date, credit card number, merchant, category, amount, all these things are there, city, state. Now you can do whatever you want with this data. So for now I just maybe I just want to check the transaction which are there on the New York City only. So I will use that filter function df.filter, and I will check df. I will check the where state equal to New York, and all it will contain the data, all the data which all the transaction which happened in New York only, New York City. But I'm saying it that only show me 10 transaction in the on the console, because it will not be easy to check it here. So you can I will show only 10 transaction. So now, so as I am running it every time, that's why it is creating it was creating section session every time. Otherwise, once the session is created, then every code will be executed in the single session.
Yeah, but then you can run the code in blocks.
Yes, yes.
So
So
is there
actually
a
in
way of doing
PyCharm,
it in this case also? What software is this?
it is PyCharm. So I have made a file here. So I'm running the whole file. I have to check how to run in the blocks. But
Blocks.
yeah, in the Jupyter notebook, as you know that once you will create the session, then after that you can run one line or one part of the code you can run, and the session will be created only once. It will not create the session again and again.
Mm-hmm.
Same thing, I think, can be done here also, but I have not explored that how to run without the file, because file, if it is a file, you have to run the whole file only. So I need to check in PyCharm how to do that. So it was like handy for me, so that I have not done all these things in Jupyter Notebook.
Okay.
Otherwise, yeah, I know in Jupyter you can do that. In blocks you can run. So you it will not need to create the session again and again. Okay, so now we can say we can see like top 10 rows has been displayed, and all the data is coming from New York City only. New state equal to, where is the state? Yeah, state equal to New York here. Okay, in the same way, if you want to check one more filter, if you want to apply it here, uh, dot filter, and we can say we want to not filter, I will do order by. I want to see the like age wise transaction, like date of birth. So what is there any date of birth column? Yeah, DOB. So I can say that order by DOB. So DF dot order by DOB. And I want to show only 20 records. So we can get the in the like the highest date of birth first, and then next. Okay, I have done something wrong. Okay, This, it should be like that. Okay, means I think it will take again take the time. I have already written this. Ascending equal to false mean it will be in the descending order. So we can see like here you can like the if the large amount of data is there and you have to analyze the data, you can take it in the data frame or in the memory, and you can do the operation whatever you want here. If you want to create some chart and graphs on this data, you can easily do that. And also if you want to take in the pandas that data frame, you can take in the pandas data frame as well. So, but in the Spark data frame, many inbuilt functions are there, which works very fast. So you can do that also. So you can see like order by it came in the ordering. Hmm. Okay, it is like that. Okay, the date is okay. There are many values where the date of birth is same. So I have displayed only 10 records and all are the same. So maybe, and after 10, maybe the records will be changed. So it will come on the order of date of birth. So that was a very small example.
Richa,
So
one
we
more
can.
question then.
Mm-hmm.
Could you please go back to PyCharm once more?
Mm-hmm.
So my question is, so let's say once you want to put this filter that arrange all date of births by in the here it says descending order. So because
Mm-hmm.
ascending order is false, it's descending order. And after that, you want to apply one more filter.
Mm-hmm.
Let's say arrange names in the alphabetical order for after applying that the date of birth come in the descending order. So how do you do that?
So you are saying you want to order by.
No, first you have done this. So first you have arranged the records
Mm-hmm.
in the descending order of the date of birth. So I'm
Mm-hmm.
saying, let's say after this you want to apply one more filter that after doing this by date of birth, you have to also arrange the names in the ascending order or in the dictionary order. How do you do that?
So many things are there. You can assign this to a, new data frame, or you can update the same data
Acha,
frame
acha,
only.
acha, 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 acha.
So you can again do this on the DF1, or in the PySpark, you can directly in this order by, there are multiple functions you can apply here again and
Order,
again.
acha, 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 samjha. Okay.
Dot something. And like if you want to select only some value, so here only you can write select DF of
Oh, so you apply
DF.
this order by again and again based on some certain criteria.
Yes. So Spark has the that kind of PySpark has this kind of facility that you can dot you can write any of the function. So if you want to do it again order by, I need to check if you have to write order by again, or if it is has the facility that you have you can do nested here only. That I need to check. But yeah, like this is very easy to do in here in the shorter way. Otherwise, I have told you the other way, like you can assign first in the data frame, or you can update the existing data frame, then again the next operation you can do in the next step also.
Mm-hmm.
That is
Okay.
obviously you can do, but there are many faster way available for everything in the Spark.
Okay. Okay.
Yeah, so dot select, then if you want to do some group by, then you can do the group by in the same line only. You want to do some filtering, then you can do the filtering also here. So
Okay.
this kind of thing you can directly do. But yeah, obviously there will be a sequence. Like first, if you have done the group by, so you can do the filter or not. That thing you have to maintain because it will go the sequentially.
And the left part will be executed first, and then it will move to the right part.
Hmm.
Okay. So in line number 15, as you have written, so it will first write write the entries in the descending order based on the date of birth, and then it will do something else.
Yeah, we can check that also. Like if you are doing select after that, so it will first order arrange order by, then only it will select. But I think if I'll write in a different sequence, then it will not work, I think. Let me check.
You did not write show.
Mm-hmm. Show time. Okay. Let me write it also in the disorder. Yeah, so that I will be also be check. So here it is selecting the first row by using order by. And now it is okay. It is working like that only also. So for the order by and select, maybe obviously it will not make any impact if you will select first then do order by. But in the some operations, maybe sequence is important. First, if you are filtering first, then you are doing group by, or you are doing group by and then filtering. Both will make the difference. So in that type of scenario, you will need the sequence.
Okay. Okay, fine.
Maybe you are getting the point. If you are filtering the data, then you are doing some operations, so the operation will be done on the filtered data only. But if you are doing the operation first and then doing the filtering, then the output will be different. So in that time, sequence matters.
Okay.
Okay. Now. Yeah, so that is the last point which I just covered briefly. So we have seen that in PySpark we are doing the in-memory processing. So we are taking the data in the data frames and we are doing the processing in the memory only. So, but yeah, because we know that it is a big data, obviously we will know the data. We will need the data storage, and we have to be like PySpark had to be compatible with the data storage part also. It means that it can store the data in the some data storage, and it can read the data from the storage itself. So in our example also we have seen that PySpark was able to read from my local storage system. So what we can say, PySpark can work with different data storage like SDFS, Hadoop distributed file system. So Hadoop distributed file system is what if you like you want to take the files, you want to store the files, for example, CSV file or some other data files. You need to store somewhere, so you can use the SDFS for that. So PySpark can work on the SDFS. PySpark does all type of processing on data, but if you want to store the data in tables or JSON files or CSV files or any other formats, then you will need to provide data storage. So, for example, SDFS, we can understand it like a database also, Hadoop database. So you can create the tables there because, or you can write the CSVs there because after processing the data, maybe you will need to store them somewhere, or like permanent storage you will need for some of for any of the scenario. So something is should be there which where it can store the data, or from where it can read the data. So storage can be cloud storage, local system, or distributed system. So from local system, we have already seen how it can read and store the data. It can be done with the distributed system, cloud storage also. So example for SDFS, if you want to store the data in SDFS, that is the Hadoop system. So again, you have to install the Hadoop for that, and then set up all the environment variable to point it to the PySpark. So that is the process of data storing also in the PySpark. So that we can store the data permanently, because in the data frame it will not be stored permanently. It is in a temporary memory. It is the purpose on for the data frames is for the data processing, data analysis only, not the storage. So finally we come to conclusion. So we can say PySpark not just a tool; it is a gateway to unlock the potential of big data. We have seen how PySpark's distributed computing, versatile APIs, and integration with Hadoop ecosystem make it a powerhouse for data processing and analytics. So it is a must-have tool for all the data engineers and data scientists these days, as it is very much useful for real-time use cases. So we can see like PySpark is very much useful these days because the data and big data handling is very much required uh, in the present scenario. Yeah, thank you for your attention. Now